Applications of systems of equations. We've worked with application problems before. We understand that they're a higher order of learning. It's not just a matter of solving a problem. You have to understand the problem, come up with a plan in order to solve it, and then execute your plan by setting up an equation, which of course in this case is going to be a system of two linear equations. But that's the last step, and one of the most important steps is make sure you completely answer the problem, make sure your answers seem reasonable. Now, most application problems are all a little bit different from one another, and there's certainly some general application problems where they all are a little bit different, but some of them can be categorized or put into specific groups. For instance, the first type of problem you should be able to recognize is what I refer to as a geometry problem, and all it is a problem that involves a geometric shape. So one of the best ways to organize the information in a geometry problem is to sketch it out. Rectangle, everybody should know, of course, 4 sides made up of a length and the width, actually 2 lengths and 2 widths. Next, everybody should be able to pull out of the problem and know the definition of a perimeter of a figure, the sum of all the sides. So in this case, the perimeter of a rectangle, you don't have to know the formula, just by definition you can come up with it. The sum of all 4 sides, the perimeter is equal to 2 times the length plus 2 times the width. Now, read 9 is not asking us to find the perimeter, it's giving us the perimeter. 127.4 is equal to 2 times the length plus 2 times the width. And then it gives us a relationship between the length and the width. It simply says the length is 1.6 times the width, so we can convert that statement directly into an equation. And now we have a system of 2 linear equations that we can solve using whichever method we prefer. I think most everybody would probably choose the substitution method in this case, since the second equation is already solved for L. So all you do is substitute it into the first equation. Allowing you to solve for W, the width. The width works out to be 24.5. Your unit, of course, would be inches. Substitute that value back into the second equation in order to solve for the length. The length then would work out to be 39.2 inches. Take a quick check. We can substitute those values back into the system to make sure they're solutions to both equations within the system, and they are. They both check out. The next type of application problem is an interest problem, which in order to do a problem like this, you have to know the interest formula. I is equal to P times R times T, where I stands for the interest, P stands for the principal or the original amount invested, R is the rate, and T is the time. So in this particular problem, and as most investment problems that you're going to be working with, you're going to see that there actually are going to have 2 investments being made in the problem. So we want to organize the information. We have the first investment, we have the second investment. Don't confuse the information because they're each going to have an interest, principal, rate, and time. So first of all, we see that the total amount invested is $5,200. We don't know how much is invested in each account, but the total amount invested is $5,200. We have the 2 rates. One is 3%, the other one 4%, so change those to a decimal. We know the investment was only 1 year, and the total amount earned at the end of 1 year, $203. So this is just the information given to us in the problem. We just have to go back and fill in the blanks. Well, we know we're going to be using x and y, 2 variables, so we're going to let x and y represent the principals, or the amount invested in each account. Therefore, just by using the interest formula, we know the first interest is equal to its principal times its rate times its time, so x times 0.03 times 1, we can simplify to just 0.03x. The second interest, its principal times its rate times its time, y times 0.04 times 1, 0.04y. So if you take the time to complete the table here, we have our 2 equations right here in front of us that will form our system of 2 linear equations. The first equation comes from the interest, 0.03x plus 0.04y is equal to the total amount of interest earned, 203. The second equation are your principals. The amount invested in the first account, x, plus the amount invested in the second account, y, must equal the total amount invested, 5,200. So we have our system of 2 linear equations. Solve using whichever method you prefer. Either method, substitution or elimination method, would work pretty well here. I'll solve using the elimination method, eliminating the x's, multiply the second equation by negative 0.03. So the first equation is not going to change. The second equation multiplied by negative 0.03, negative 0.03x minus 0.03y is equal to negative 156. Add the two equations together. That allows us to solve for y. Y is equal to 4,700, which makes x equal to 500. So we include our units, dollars, but we have to understand what these two variables stand for. X was the amount invested at 3%. Y was the amount invested at 4%. And that's important. If you get them backwards, it would not check out. It basically would be wrong. Next type of application problem is a mixture problem. Overall concept here, two things are being mixed together, and if you mix two things together, it's going to form something new. So the two things that's being mixed together we'll call solution A and solution B. So if we're adding them together, or if we're mixing them together, of course that's addition, adding them together, it's going to form something new we'll call solution C. So we already see kind of the structure or the backbone of an equation forming here. For each one of these three solutions, we're going to have a percent and an amount. A percent and an amount for each one. So just read the problem. Should be easy to recognize a mixture problem like this. And fill in the information we know. We know the percent for the two solutions that are being mixed together, 0.20, 0.50. And we know the percent of the final solution is going to be 30%, 0.30. We do not know how much of solution A or solution B we need, but we are given how much of solution C, the final product, we need 18 ounces. So we have two missing spaces here, which works out well because we know we're going to be using two variables, x and y. So I'll neaten this up a little bit. 0.20x plus 0.50y is equal to 0.30 times 18, 5.4. So we have one equation, but we know a system of linear equations, we need another one. Well, the second equation is just going to deal with the quantities or the amounts. The amount of solution A plus the amount of solution B must equal the amount of solution C, 18. So now we have a system of two linear equations. Once again, you can solve using whichever method you prefer. Just because it's a little bit quicker and pretty easy, once again I'm going to solve using the elimination method. Eliminating the x's, multiply the second equation by negative 0.2 or negative 0.20. So the first equation does not change. The second equation becomes negative 0.20x minus 0.20y is equal to negative 3.6. Add the two equations together. 0.30y is equal to 1.8. So y is equal to 6. If y is equal to 6, we can easily substitute that back into the second equation, which makes x equal to 12. Include your units. The units are ounces. And once again, understand which one is which. Y, 6 ounces of the 50% solution, and x, 12 ounces of the 20% solution. Which should have been kind of what we anticipated. If we're mixing a 20% and a 50% solution together and we're forming a 30%, 30 is closer to 20 than it is to 50, which means we should have expected to have more of solution A, the 20% solution. And we do. We have twice as much. The next type of application problem is what's called a motion problem or a distance formula problem. Here, something's moving at a particular speed or rate for a certain amount of time. It's going to travel a certain distance. So you have to know the distance formula in order to do the problem like this. D is equal to rate times time. And in this particular problem, an airplane, same as a boat, the speed of the airplane is affected by an outside factor, the wind. So even though this plane may tell you you're going 100 miles per hour, that doesn't mean you're going 100 miles per hour. The wind is going to make you either go faster or slower. Same thing as a boat. In a boat, you have a current. The current will either make the boat go faster or slower. So we have two parts of the trip. The first part is the tailwind part. Here the wind is coming up behind you, which is going to make the plane go faster. Then when you turn around and go home, you have a headwind. You're going into the wind, so it's going to slow you down. So in this problem, we're going to let x represent the speed of the plane with no wind. And we're going to let the variable y represents the wind speed. So the tailwind, we're going to represent the rate as x plus y, the speed of the plane with no wind, plus the speed of the wind. For the headwind portion, x, the speed of the plane with no wind, minus the speed of the wind it's slowing you down. So what we know from the problem, the distance 240 for each part of the trip, 240 miles, and the time for the tailwind 3. Since you're going slower than the headwind, is going to take longer, 4 hours. So right here we have our system of two linear equations. 240 is equal to 3 times x plus y, and 240 is equal to 4 times x minus y. Now typically, of course, we would distribute that 3 and 4, but if you notice in this case, 240 is divisible by 3 and 4. So if we divide both equations by 3 and 4, that way the numbers will be smaller, easier to work with, and we'll still come up with opposite coefficients for the y's. So now when we add the two equations together, the y's eliminate, leaving us just x. X is equal to 70, which was the rate of the plane with no wind, so 70 miles per hour. And that's all the problem was asking us to find, was the speed of the plane with no wind. So in this point, we're done. The next application problem is just a general application problem. Read the problem, understand what's going on, what we're asked to find. Two things: the amount of general admission tickets sold and the amount of reserved tickets sold. So that's what we're going to set our two variables equal to, x and y. So come up with a system of two linear equations. The problem deals with two different types of information. One is just attendance, the other is money. So we're going to have one equation represent money, the other one attendance. So it tells us that the general admission tickets were just $5, so we represent that as 5x. The reserved were $14, so 14y, and that's going to be equal to the total amount of revenue for ticket sales, 340,000. The amount of general seats plus the amount of reserved seats is going to be equal to the total number of seats or attendance, 41. So now we have a system of two linear equations. Once again, solve using whichever method you prefer. I'm going to solve using the elimination method, multiply the second equation by -5, so the first one does not change. Second equation, -5x minus 5y is equal to -205,000. Add the two together, 9y is equal to 135,000. So y is equal to 15,000, which makes x equal to 26,000. So which is which? Y was the amount of the reserved seats that were sold, and x was the general admission ticket seats sold. Some extra practice. Example 1, read the problem, identify what type it is. So this is just similar to the previous problem, just kind of a general application problem. Two unknown values, x would be the number of adult ticket sales, y would be the amount of child ticket sales. So same thing, one equation is going to represent money, the other attendance. So an adult ticket was $9.50, so 9.50 times x plus a child's ticket, 7.75. Y is going to be equal to the total amount of revenue, $837.25. Second equation is just going to represent the attendance, number of adults, and the number of children must equal the total amount in attendance, 92. So here's our system of two linear equations. You can solve using whichever method you prefer, which we've solved enough of these, so I'll let you do that on your own. X should work out to be 71, y will work out to be 21. which means X was the number of adults, Y the number of children. Number 2, another distance formula problem. So distance is equal to rate times time. In this case, we have the boat, where once again the boat speed is affected by the outside factor, the current. So we're going to let X represent the kayak speed with no current, and Y, of course, would be the current speed. So set up the problem. The first part of the trip is the upstream portion. Then you turn around and go downstream. So upstream, the current is working against you, so we're going to represent that same as the headwind in an airplane, X minus Y. The downstream, X plus Y, same as the tailwind. It's making you go faster. Tells us it's going to be a 12-mile trip for each portion. The amount of time for the first part, the upstream, was 6 hours, and only 1.5 hours for the downstream. So 12 is equal to 6 times X minus Y. 12 is equal to 1.5 times X plus Y. System of two linear equations, which once again, instead of multiplying both equations by a number, we're going to divide in order to come up with opposite coefficients. That's going to give us 2 is equal to X minus Y in the first equation. 8 is equal to X plus Y in the second equation. Add the two equations together. 10 is equal to 2x, so x is equal to 5, which makes y equal to 3. Include your units. These were rates, so miles per hour. X was the speed of the kayak. Y was the speed of the current. Number 3, read the problem, understand what type of problem it is. So I think we all agreed this is a mixture problem again. So the same overall concept. Two things are being mixed together, which we call solution A and solution B. And if you mix two things together, it's going to form something new we call solution C. So for each one of these, we're going to have a percent and an amount. So the percents is telling us the first one, 12%, so change that to a decimal, 0.12. The second solution being mixed together, 18%, becomes 0.18. In the third solution, we're forming a 13.5% solution, or 0.135. We do not know how much of solution A we're going to need, so that's X. Same thing as solution B, we set that equal to Y, but we do know how much we're going to form. We're going to form 36 pounds. So neaten this up a little bit. 0.12X plus 0.18Y is equal to 4.86. So we have one equation with two variables. Now we just have to come up with another one, which is going to involve the amounts or quantity. So X plus Y is equal to 36. So now we have a system of two linear equations, which you can go ahead and solve using whichever method you prefer. We've done a number of these. X will work out to be 27. Y will work out to be 9. Include your unit, pounds. It makes sure you understand which is which. X was the amount of the 12% mixture, 9 pounds of the 18%. And example 4. Read this problem, understand what type it is. Another investment problem or interest problem, so you have to know the interest formula. I is equal to P times R times T, where once again two investments are actually being made. So we need to organize the information, make sure we don't confuse which information goes with which investment. So the first number we see in the problem, 32,000, the total amount invested between the two accounts. One is at 7%, one is at 3%, so change them to decimal, and the time once again is 1 year. The total amount invested, interest earned, total amount earned in the investment, 1760. So we're going to let our two variables, X and Y, represent the amount invested in each account. X will be invested at 7%, Y invested at 3%. Now substitute in values for the interest using the interest formula. First interest in the first account, its principal times its rate times time, X times 0.07 times 1, 0.07X. The second interest, its principal times its rates times its time, Y times 0.03 times 1, 0.03Y. So we have our two equations. One equation represents the interest, the other represents the principals. So a system of two linear equations, 0.07x plus 0.03y is equal to 1760. X plus y is equal to 32,000. Solve this system. X will work out to be 20,000. Y works out to be 12,000. Include your unit, dollars, and which is which. The 20,000, X was the amount invested at 7%. Y, $12,000, the amount invested at 3%.